Recognizing that decoding by match filtering discussed below happens over the time duration t. Inaccurate duration timing results in partial correlation. Recognizing that decoding by match filtering discussed below happens over the time duration t. Inaccurate duration timing results in partial correlation. Inaccurate duration timing or due to among other factors inaccurate synchronization between the transmitting channels as well as propagation delay. The phase relationship between duration timing of different transmitters can be arbitrary. The phase relationship between duration timing of the phase relations duration timing of different transmitters can be arbitrary. Let us go to figure 1.4b which are for two channels, channel 1 channel 2 with the channel response H1 and H2 having difference in the delay given as tau, the delay on the tau. Since they can interfere each other, correlation between them, partial correlations should be 0 to maintain orthogonally. That is integral over 0 to t minus tau h1 of t h2 of t plus tau dt equal to 0 and integral over t minus tau to t h1 of t h2 of t plus tau minus t dt equal to 0. அதாவது let us go to figure 1.4b which are for two channels, channel 1 channel 2 with the channel response h1 h2 for according to channel 1 channel 2 that is channel 1 h1 channel response channel 2 response h2 having difference in the delay even and the difference on the tau level. Since they can interfere each other, every interfere correlation between them, partial correlations should be 0 to maintain orthogonally integral over t to t minus tau h1 of t h2 of t plus tau dt equal to 0 and the integral over t minus tau t h1 of t h2 of t plus tau minus capital T dt equal to 0. In reality, since tau varies, these two partial correlations are not identically 0. In reality, tau vary agala. These two partial correlations are not identically 0 but theoretically we are having identically 0. The goal should thus be to reduce them under any way of tau. The goal should thus reduce them under the any value tau குறைக்கணும். இப்படி since the variability in tau increases with the number of pieces பொறுத்து tau உடைய value increase ஆகுது, variability ஆகுது. Achieving this goal means restricting the number of pieces. So number of pieces restrict பண்ணணும். This number is typically fewer than that it in TDMA and the FDMA case. This number typically கம்மியா இருக்கு than எதை விடனா TDMA and FDMA விட. இப்போ OFDMA போய் பார்க்குறோம். OFDMA another approach to allow multiple access is OFDM. OFDM multiple access ஏன்னா மேல user கம்மியாச்சுல. Similar to CDMA, OFDM achieves this by exploiting the orthogonality property. CDMA மாதிரி OFDM achieve பண்ணுது exploiting orthogonality property. Unlike CDMA, where the orthogonality is between sequence code assigned to each transmission waveform, here orthogonality is between the carriers. Unlike CDMA where the orthogonality is between sequence code sequence assigned to each transmission waveform. Here orthogonality is between carriers. Okay, hence OFDM consists of multi-carrier transmission. OFDM multi-carrier transmission. Specifically, a single high rate carrier data stream is transmitted over numerous lower rate subcarriers. SC. Specifically, a single high rate carrier data stream is transmitted over number of lower rate subcarriers. In that sense, in addition to being an access approach, it can also be seen as a modulation technique. Modulation technique is discussed in next section. In that sense, the addition is being an error access approach. It can also be seen as modulation technique. Okay, in a straightforward implementation of multi-carrier transmission, straightforward multi-carrier transmission implement பண்றது எப்படின்னா, the single frequency band is divided into n disjoint frequency subchannels, each modulated with a separate symbol. அதாவது single frequency band எப்படி டிவைட் பண்ணோம்னா n disjoint frequency subchannel modulated with எப்படி modulate பண்ணோம்னா separate symbol வச்சு. The subchannels are then multiplexed in the frequency domain. Subchannel எப்படி multiplex பண்றோம்னா in the frequency domain. Because the subchannels are non-overlapping, interchannel interference is eliminated. Yes, subchannel overlapping ஆகக்கூடாது, interchannel interference is eliminate பண்ணிடணும். The disadvantage of this is obviously an inefficient use of the spectrum. The disadvantage என்னன்னா obviously an inefficient use of the spectrum. Spectrத்தை யூஸ் பண்ண முடியாது, inefficient. To overcome this, overcome பண்ணா overlapping subchannels can be used instead. Overlapping subchannel can be used பண்றோம் இது பண்ணலாம். Such an overlapping multi-carrier techniques is shown in the bottom of figure 1.5 கொடுத்திருக்காங்க. இந்த overlapping multi-carrier technique யூஸ் பண்ணது. Here there are 8 subcarriers. இந்த figure 1.5 8 subcarriers இருக்காங்க. For comparison, the conventional multi-carrier approach conventional multi-carrier approach is shown on the top where there is no overlap. It can be seen that the savings in bandwidth is close to 50%. To realize these techniques realize பண்றது எப்படின்னா, however we need to reduce crosstalk between SC. அதாவது crosstalk between SC reduce பண்ணணும், which means orthogonality is required, and hence the technique is called OFDM. The orthogonality required பண்ணா and hence the technique என்ன சொல்லணும்னா OFDM சொல்றோம். This dictates that the separate frequencies follow a mathematical relationship. The dictation separate frequency follow the mathematical relationship. In contrast, in a typical FDMA system, no such relationship is required. Also shown in the bottom of figure 1.5a is an example channel. இப்போ OFDM compact fading conventional multiplier exercise frequency conventional multiplier. subcarrier subjected to fats, savings in bandwidth, example channel response, delta F OFDM. OFDM multi-user access. OFDM compact fading x is conventional multiplier in frequency. இங்க இது வந்து delta F OFDM in frequency. Example channel response, savings in bandwidth. அடுத்தது OFDM multi-user access. அது வந்துட்டு user A, this one, and this one user B, and then this one user C, user D. Okay. Response with response. Okay. Now coherence bandwidth delta F C the B subcarrier subjected to fats. Seen only part of the subcarriers, the middle core are subjected to fading under this example channel, and so OFDM on the more robust towards fading. This will be explained in more detail later in section 1.10. After the concept of fading and the coherence bandwidth is introduced பண்றோம். Next we turn to figure 1.6, which shows how OFDM can be used for access. Let us assume that are 4 users A, B, C, D இருக்கு. Users வந்து A, B வந்து are each allocated 2 bands, which users C, D வந்து are allocated 2 bands. Notice through the multi bands for each user are not adjacent, unlike in FDMA case. Notice through the multi bands for each user are not adjacent, unlike FDMA adjust பண்ணாது. This means if again due to fading coherence bandwidth சுமாரா இருக்குது, one of the multi bands will be affected. With example, deep fade happen at the first band, however second and third bands are not affected. In this sense redundancy is built in. In addition, because right now a variable number of channels can be assigned to different users. That means the bandwidth allocated to a particular user is flexible and can be changed dynamically. In addition, because right now a variable number of channels can be assigned to different users. That means the bandwidth allocated to a particular user is flexible and can be changed dynamically. Modulation schemes. There are many modulation schemes for transmitting digital data from the transmitter to the receiver in wireless communication. We focus on the modulation scheme that will lead us to MSK, as it is commonly used in most wireless standards, including DECT. More comprehensive treatment on modulation schemes can be found in one lab. The choice of modulation scheme influences performance such as BER, bit rate, SNR, signal to noise ratio, and message bandwidth. This can affect the receiver design in both high and low level fashion. At the high level modulation scheme can be